All right, pre-calc guys, this is the video that goes along with section 2.2. This is the practice page that I'd like you to do, and I'm going to give you a little information on how to attack this, or what we talked about in class, or what you should know about polynomial functions. You already know a lot about functions just because of the previous information. So for instance, we're taking a look at this function here. I'm going to really blow it up so you can see it. Just give me one brief moment while I blow it up. There it is. Here's our function, negative 7x to the fifth minus 2x cubed plus 3x squared plus 5. That's a function of x, right? So we know a lot of things. This is going to be some sort of graph that has that x cubed type function, that odd function that points in both directions. It happens to be negative, so I can't draw it like this, can I? I have to draw it the other way, because it's negative. So it's going to start on the left and swoop down to the right. So I already know one little bit of information, and I can start to draw this function if I felt like drawing it. I don't feel like it right now because I have to do a couple more things. We're going to learn a couple more things about this. We're going to learn how to perform the leading term test. All right, the leading term test. Well, you have to know what the leading term is, and this is the leading term, right? It has a lot of information embedded in it. We already said it's an odd function. It's got to have arrows pointing in both directions with one little squiggle. There it is. There may be some bumps. We'll talk about those in a minute. We know it's negative, so it starts on the left and moves downward, right? Okay? And then with this information, we've got our start. Now we have to look at this exponent, at this power right here. All right, so if the power, we said, is odd, we're going to create this. But the power is equal to the number of possible zeros. Oh my God, what are zeros, right? Well, they're also called roots. So zeros, possible zeros or possible roots, are those moments where this graph crosses the x-axis, all right? It helps us to graph if we know where it crosses the x-axis. So that power in the lead term tells us how many possible times this is going to cross the x-axis, how many real zeros there could possibly be. Right? Now, they may not all be real zeros. They may be imaginary or complex numbers, and then they wouldn't exist on this graph. They would exist on another plane, which is down the road. Don't worry about that yet. All right? You'll think in 3 dimensions later. Then we can also know that if you subtract 1 from that lead power, so power minus 1 tells me the number of possible turns. So this function has a possibility of touching the x-axis 5 times, and it could possibly turn back and forth 4 times, right? Because it'll turn once, it'll turn back. It'll turn once, it'll turn back. So in essence, this function could very well do this, and that, right? 1 turn, 2 turns, 3 turns, 4 turns. It could look like that. These could be stretched. It could look like that. Now, for our purposes, I want to just think about the information. Look at that. There's a y-intercept. It's that concept there. That we already know. Y-intercept, that constant tells us it's going to cross the y-axis at 5. All right, so we've graphed our point, and we've made sure that our graph points in both directions. And that's really all I needed you to do for that. The other one is a quadratic, basically, but it does have some bumps and turns. So I'm going to leave this up, but I'm going to move to that next function. Just slide it over here. There it is. So our lead term is x to the 6th. Our lead power is 6. So it could possibly touch this x-axis 6 times, but it might not. All right? I already know what this looks like. I've input some values, and I know it has a y-intercept of 1. It's going to point up in both directions because it's positive and it's even. So it's got that parabola view. And as a matter of fact, I know that it zeroes out at 1 and negative 1, 1 and negative 1, and I know it looks like this. All right, a little curvier than that, but we also know it had the possibility of turning 5 times. It really only turned a few times, right? Turned once, twice, and then a third time. But that's only because it had the one term in here. Sometimes when there are more terms in there, you'll get more turns of your graph. So that's really all there is to it. It's not a huge, difficult concept to worry about. You're going to go ahead and analyze more of these. If I look down here, you have a couple of functions that you're going to factor. The first one here, we're going to use 2 different styles of factoring, all right? Determine the possible number of zeros and turning points, and then factor to find those real zeros. That's what this says, all right? Now, the lead term is x cubed, so it has the possibility of 3 real zeros, and then it has 2 possible turning points. Okay, well that makes sense. It's an odd function. It's going to turn and then turn. That's what an odd function does, right? It turns and then turns. So it's going to look just like that. Well, not just like that, because that's a really rotten job of drawing, but you understand what I mean. So let's go ahead and determine those real zeros by factoring. Okay? Can you look at this and just automatically say, hey, Sokol, I know how this works. I can factor this? No. I don't know off the top of my head what those factors are. But you can use factor by grouping. Remember this concept. And if you don't remember the concept, go ahead and type in on YouTube factor by grouping, and somebody's going to show you how to do it. Here we go. Here's factor by grouping. I group this. Keep that sign in there, and I group that. So now I have 2 groups, and I'm going to look for, inside these groups, a common factor. All right? Well, a common factor here, they have 2 x's in common, so I'm going to pull out an x squared. Sounds cool? There it is. And when I divide x cubed by x squared, I get x minus divide by x squared, I just have 3. Okay, well, I want to see if I can make this look like this. Because if I have 2 of them, then I do have a common factor, and when I'm finished with all this fun stuff, I want to have one of those left over because I'm pulling it out of both. I want to see if it's a factor of both of my groups. So, what can I do? Oh yeah, I can divide or pull out a -1, right? And if I divide this by -1, I have x, a positive x, and then a positive 3 divided by -1 is -3. Hey, look at that. They look exactly the same. So that's one of our factors. We put these 2 together down here. We have x minus 3. All right? And then here's our big, big, big reveal. We take this guy, this -1, and this x squared, those things that we've factored out, and we put them in parentheses. We put x squared minus 1 into parentheses. Now I can break this down further. This, if you look at it, x squared is a perfect square, 1 is a perfect square, and it has subtraction in the middle. And that is a difference of squares. So to break this down, I'm going to do it over here. I know that I have plus and minus and an x times an x, because that gives me x squared. What times itself gives me 1, 1, and 1. And if you don't believe me that this is this, pause the video, finish watching the video, whatever you want to do, go ahead and say, FOIL that, and see what you come up with. And trust me, you'll come up with that. All right, so these are the 3 real zeros. Well, these are the 3 factors that I get when I break this down and factor by grouping. Now, what minus 3 gives me 0? 3. What plus 1 gives me 0? Negative 1. And what minus 1 gives me 0? Positive 1. So, when you graph this, it's indeed possible to have these points on the x-axis where this crosses, and here we go. I put a point at 3, 0. I put a point at 1, 0, and negative 1, 0. Look pretty good? That's about it. So you have more information. You do have some information there that you have 0, 3, right? You have a y-intercept here in your original function. So you can see it probably comes down here, crosses down there. Oops, I did it backward, but you know what I mean. But it gives you information. Now, if you want to know whether any of these do or don't work, you can plug these numbers back in and see if you get a 0. Other than that, we should be good to go. So you found the real zeros by factoring. There's another one here. If I slide this over, this one is simple factoring, just like a quadratic, only it doesn't look like a quadratic, does it? It's got a power of 4, but it is positive. But imagine, if you will, this was a 2 and that didn't exist. We could just say x minus 9 and x plus 4. Those are the 2 factors of 36. And when I find their difference, I get negative 5. All right? So negative 9 times 4 is negative 36. Negative 9x plus positive 4x gives me negative there. Now, I want my middle term to have x squared, so those are squared, right? Because x squared times x squared gives me x to the 4th. There it is. We've broken that down with regular factoring. If you need help with factoring polynomials or factoring quadratics, there are lots and lots of videos there. I think I've actually posted some videos earlier this year about factoring quadratics. Other than that, you should be good to go on this. There's some information at the bottom, but it's already factored out. So you just tell me a little bit about what you know about that. And that's it. Thanks for your time. I'll be back.